Hi, today we are going to see about the unit of activation devices. So in activation devices, so many devices are available in the recent technologies such as digital energy meters, smart meters, accelerometer, touch controls, IR control and gyroscopes, and so many activation devices are used in the current IOT electrical trends. Today we are going to discuss about the gyroscope. And we know that the accelerometer and gyroscope are different from each other, and the accelerometer is used to measure the linear momentum in x direction, y direction and z direction, but in gyroscope it is used to measure the angular rotation of the particular object. It is, for example, whenever the human being is feel difficult to measure the angle or sense the angle, means we can use the gyroscope as the instrument which is used to measure the angular rotation of the particular object. And this gyroscope is also known as the angular rate sensor or angular velocity sensor, and it is also known as the gyrosensors. And what gyrosensors can do means it sends the rotational motion and it sends the changes in the orientation of the particular object. And because it motion that human have difficulty in sensing area, and human can reach the very difficult area, means we can use the gyroscope to sense the particular rotation of the object. And the gyrosensors is used to sensing device that effectively augment the human motion. And before that, we want to know about the angular velocity. So we also know that what is angular momentum or what is angular velocity or angular rotation means the device which is used to rotate the in a 360 degrees. Based on the rotational angle, we have to calculate the angular velocity by per unit time. In simple terms, we can define the angular velocity as the change in rotational angle per unit of time. And angular velocity is generally expressed in degrees per second. And gyroscope. First we see about the construction of the gyroscope. The gyroscope construction, it includes the base, and after base it has three rotational parts, that is the outer circle is known as the gyroscope frame and the inner circle is known as the gimbal, and inside the inner circle it is called rotor, and the central axis is called as the spine axle. And the gyroscope, the working principle is based on the gravity, and it is the product of angular momentum which is experienced by the torque that is produced by the gyroscopic presentation due to the rotation of the spinning wheel. And gyroscope sensor is used to measure or maintain the orientation and angular velocity of the object. And compared to accelerometers, the gyroscopes are advanced than the accelerometers. And the gyroscope is used to measure the tilt angle and lateral orientation of the object, whereas the accelerometer can only measure the linear motion. In first itself, we saw that the accelerometer is used to measure the linear motions, that means the x-axis, y-axis and z-axis direction. But if we want to measure the rotational angle, means we can choose the gyroscope. And the gyroscopes are mainly used in MEMS systems, that is micro electromechanical systems. The technology is very small electromechanical and mechanical devices. In advanced MEMS technology, it is used to help us to develop versatile products. And the gyroscope sensors, we know that we call it as an angular velocity sensor and angular rate sensor, which is used to detect the orientation of the object difficult to sense by humans. And we know that it is measured in degree per second. And in gyroscope, it is the three orientations are three direction of angular rate measurements can be done. The first one is a yaw, and second one is pitch, and third one is roll. The yaw means the horizontal rotation on flat surface and seeing the object from the above one. And pitch means it is the vertical rotation as seeing the object from front side. And the roll means the horizontal rotation and seeing the object from our front side. And this is the gyroscope rotation based on it is the normal drive arm vibrations. In first it is this is a stator one, and these two are called the drive arms, and this is called the stationary arm or sensing arm. So due to the vibration, it will rotate from right to left and left to right. So due to this right to left rotation and left to right rotation, it is the cancelling will be occur due to the rotation. The stationary point will be in static one. And the direction of rotation may be in the clockwise direction or anti-clockwise direction. And when the gyroscope is rotated, the Coriolis force acts on the drive arms, so it produces a vertical vibration. We know that the Coriolis force is in the same effect and the Earth's equator and north and south poles. And the gyroscope sensor, the sensing arm, sense the difference between the sensing motion from right to left and left to right. So the stationary parts like bends due to the vertical arm vibration, it producing the sensing motion in the sensing arms. And the gyroscope sensor, the motion of pair sensing arms produces a potential difference from angular velocity is sensed. Then the angular velocity is converted to an output which is in the form of electrical signal. And the gyroscope is a T structure and it has a drive arms. It is used to move the upward and downward direction, and drive arms are also symmetrical. And gyroscope sensors mostly used in mobile phones. That is, the Apple iPhone is the first smartphone which is used by the gyroscope sensor. And applications of gyroscope sensor is used to measure the sensing angular velocity and sensing angles such as the navigation and game controllers, sensing control mechanisms like camera shake and vehicle control. Thank you.